Hi, welcome to Stack Chaser. Today we'll be diving into the Spring Boot stack. We will start by using Spring's own cookie cutter tool to generate a project that fits our needs, and we will introduce various concepts as we build application. Let's get started. I've been working with Java for several years, and in this tutorial, I'm assuming that you already have some Java knowledge. If you don't, feel free to leave a comment, and I would be happy to create a separate video to help you get up to speed. What exactly is Spring? Back in the early 2000s, the technology that was used to create enterprise applications using Java was J2EE and Enterprise Java Beans, EJB. These, and especially EJB, were difficult to configure, had a lot of overhead, poor performance, and were unnecessarily complex for many use cases. The early version of Spring in around 2003, if I remember correctly, Spring aimed to simplify the enterprise level Java development by providing a lightweight alternative to EJBs and in some aspects J2EE as well. One of the core features that Spring introduced was inversion of control. Um, we call that IOC in short form. The inversion of control container was introduced as a core feature along with DI dependency injection, which enables inversion of control in many ways. This allowed developers to manage the relationships between different objects that we usually create in a standard application using Java. Inversion of control means that the objects that we create or we manage um, and their dependencies, um, the control is inverted and an external container like Spring, or there are other IOC containers as well. So the external container will start managing these objects for you. This is important because the most infamous or the infamous new keyword, which we commonly use to create objects in Java, pretty much doesn't exist in a Spring application. Instead, Spring creates and maintains the objects for you. New keyword creates coupling. Spring tries to decouple from that. And this is also where dependency injection comes into play, but I'll explain that with an example later on. To start with, I've opened Spring Initializer. This is the cookie cutter tool that I was talking about earlier. The build tool that I'm using is Gradle with Kotlin. Kotlin is a little nicer to work with than Groovy and Maven. And the language that I've selected is Java because this is the Java tutorial. Please leave a comment if you would like to see a Kotlin Spring Boot tutorial with the same kind of application, but Kotlin is a little less verbose than Java. Certain patterns are different or can be implemented differently in Kotlin. This version doesn't really matter for us. The group artifact and package are all project metadata. This is standard Java project metadata. This is available in Maven. This is available in Gradle. We're choosing jar. We do not in the Spring Boot application lifecycle. We don't really work with vars anymore. I'm not saying it has never worked with, but jars work perfectly fine, and it is a single artifact that you can have with all the dependencies in a single jar file and loaded into JVM using a single command. A web archive war file requires exploding the war file, which is like unzipping or untarring or whatever. The opposite of archival is that needs to be done in a servlet container. And the for example, a servlet container is a Tomcat. A Tomcat application server is a servlet container and a web server together. We'll work with jar, as simple as that. 21 is the installed Java version in my case. And let's look at the dependencies. I've used something called Lombok. Lombok is a lifesaver in the Java world. Well, obviously, some hate it, but Lombok enables us to use some annotations which are compile time annotations, and these annotations are markers for Lombok preprocessor to look at the source code and auto generate the code for you. So let's say you have a lot of attributes or fields in your Java class. You want to write a bunch of getters and setters. In IntelliJ, it's a simple shortcut, but in Lombok, it's one line of code, one line of annotation that says at getter, at setter, for example. And the compilation, when it happens, would generate a class file with getters and setters included. So it's Lombok is a lifesaver for me. Spring Web is Spring MVC was the first. If I remember correctly, Spring MVC was the first module from Spring after Spring Core and Spring IOC containers were released, and Spring MVC was the answer to servlets, and Spring Web is MVC plus REST and a few other technologies or advancements from Spring MVC. There is a default embedded container Apache Tomcat. You can use, I think, Jetty and Undertow. Undertow is the container, servlet container for Wildfly, if I remember correctly. And we'll also use Spring Boot Actuator just to show you what happens when we deploy or we run the application locally, or when we try to deploy it. How do we check whether the application is up and running? There are available metrics by default, metrics available for us to see the health of the application or the different metrics around it. If I click on generate, the boilerplate will be created, and I'll just load it in IntelliJ and continue the session. I've now loaded or opened the Spring Boot to do app that we created using Spring Initializer into IntelliJ. Just waiting to get this imported successfully. And while we wait, we'll have a look at what each of these files are. So I need to enable a setting so that I can zoom easily. Bear with me for a second, please. Okay, I'm back. So settings.gradle is a Gradle file, Gradle configuration file, where you can mention the root project name. There are many other configurations available. And what we give here is what we show, or what will show up in the project section. There's also build.gradle, and if we zoom in, we'll see that there is web, Lombok, actuator, and a few other dependencies. So this is the annotation processor that I was talking about. Lombok annotation processor looks at all the annotations at the time of compilation and auto generates the code for you. Still waiting for the Gradle project import to complete. Also look at a few tests. I have to set up SDK. It was a couple of clicks. It's extremely hard to do it in Eclipse. I don't know why it is like that. Not hard, but too many clicks in Eclipse. IntelliJ, one click. We do have some boilerplate tests available. We are going to delete this. This is not a good practice. This is not a good practice. It is not a good practice to include Spring Boot test with no constraints and just load up the entire Spring Boot application, because over a period of time, these tests will take a long time to run, because the Spring Boot, as soon as you call Spring Boot test, the whole Spring Boot application needs to load up. We'll revisit this. I'm just waiting for the Gradle project import to complete. All right. Finally, Gradle import is completed successfully. Project is loaded in IntelliJ, and we can start our to-do app, developing our to-do app. Um, what you're seeing here is the main class. A main class is a class with public static void main. As you can see, it is annotated with Spring Boot application, and this annotation basically enables Spring to take over using IOC. The IOC container, it takes over our application. And what is written in the main class is Spring application.run. This is a static class method that is available within Spring again, which loads this app, this class, and all the classes and configurations within this class package. So all the classes under stack.chaser will immediately be loaded, scanned, and loaded by Spring IOC container. That's all through Spring Boot auto configuration magic, what we call as some of magic in Spring world. But there is code behind it, and you can explore that code using if you have IntelliJ, just going into the run application. I do have to download some of the sources, and you will see how exactly these the class path scanning and loading of different classes and setting up the beans and configuring different areas of the application, different modules. All of that you can look up by using the source code from Spring. For our tutorial, we'll not dive too much into the internals of Spring. Again, let me know if you need a tutorial around that. All right, let's start with our basics. We are going to set up an application with a to-do application with some basic principles of Spring Web MVC. So what is MVC? MVC is Model View Controller. It's an architectural pattern, or a layered architectural pattern that is available in different domains, different ways of writing an application. I read somewhere, or maybe I read it, saw it in a YouTube video. MVC was primarily a hardware based or something to interface with the hardware. I think it was Uncle Bob who was mentioning that. And the web world just adopted that and started looking at every web application as an MVC application. Model view controller, model being the model with which we communicate each other, controller being the controller of the or the orchestrator of different activities, and a view is basically a view, in this case probably a web application. But the world has moved on to much better, or not better, much simpler architectural patterns. But we are going to attempt an MVC in a classic Spring style. Many tutorials in Spring follow this package style, and I'm going to use that. And once the version 1 is complete, we will then look at a clean architecture pattern. I'm going to create a few packages. So controller, service, and we don't have any database right now, so we'll not create any more packages. Let's start with the controller. And here is what I want to introduce. Here is where I want to introduce tests first. So how would we test all of this application? Is this application test ready is the first question that I would ask. Tests are incredible documentation around what an application does and how an application should behave. If you have been trying to write documentation for your application, please don't spend time in a Word document or a canvas like Miro or Mural. Go and write more tests. tests eventually become the documentation that we can trust on. Documents always try to catch up to the evolution or the changes that are in an application. Tests almost always are an immediate outcome of development. And if you follow test driven development, tests are written first before any source code is technically written, in most cases at least. And um, that becomes documentation first then. So please go ahead and write tests first instead of writing a documentation or a README page for your application. Again, if you have time, if you get time, that is. Before we break into the next video, I've just written a few README items, tasks for us to complete or for us to attempt as a V1, version 1 of the to do app. And what I've written is we need a controller, we need a REST API, because we are trying to create a REST application. If I didn't say that earlier, I'm saying it now. We need a REST API or an HTTP API with JSON data structure for all get all to do's, get one to do, update one to do, delete one to do, create one to do. And once we have that layer completed, we'll then add a database and integrate with all the above operations. So the first controller will be just in memory, and then we will add a database so that we can save and update and all those operations. And then we'll add a Swagger doc, which is the API documentation that we want to expose to any client who wants to integrate with Todo. In and we'll see you in the next video.